today what I would like to discuss is how one can build a career in data science. So, from a non-programming background, is there any scope for someone to get into data science? Is something that I would like to address, and then what you should do. Let's say if you don't have a background in data science, what you should do, or in programming, what you should do to get into this field, and what are the steps? Okay, where do you start? Which course do you study? And do you have to pay for something? Or is there any free materials that are available? So those are the aspects that I would like to start. Of course, I just don't want to just show, okay, read this and all. I'm planning to show a small demo as well, like how we will take up small data sets. What do we do as a data scientist generally when we get a data sets, or when we get some project? Like, what do we typically do? What is data science is all about? For few people it might be completely new. For few people, you might have heard these terminologies, like, okay, there is a separate department called artificial intelligence. What do they learn? So you might have got some background about it, but typically what do we do in data science is what I'm trying to cover today. So as I said, agenda is we'll see what is data science, and where there is why we have so much of demand in data science, and how do you get started, basically what courses to study, and how do you build your profile to at least apply for jobs in data science. And then we'll also look at some live demos if possible, and I'll have towards the end we'll have some open discussions around it. I would like to start with a simple example that everyone understands. Okay, and then I would like to introduce what is data science. So I would like you guys to open up your chat window and tell me, when you go for a supermarket, or let's say when you buy stuff in Amazon or Flipkart. Let's say you have a cart, multiple items are there in your cart. Let's say 10 or 15 items. Let's say if you're going to supermarket, you might be buying certain grocery items, you might be buying certain household items, or if you're in Amazon, you might be buying certain electronics, or you might be buying certain apparels. So let's say whether you're going in person into a store and buying something as a customer, or you're buying something in Amazon, not just one product, multiple products are there in your cart. What do you think? What does this supermarkets or e-commerce websites collect while billing? Can you put it in the chat window? So I'll show you a data to start with. With an example, we'll try to understand what is data science, because I would like to always learn something from examples rather than looking at PPTs. So I'm going to open up a data set. Don't worry about, I'm not planning to do any analysis right away, just trying to show you how data gets collected behind the scenes when you do some purchases, and that will clearly give us an idea about what is data science is all about. Yeah, let it get downloaded. Meanwhile, there are a lot of data sets or data that gets collected behind the scenes. For example, as you said, invoice details. So every invoice will have the following details, like phone number, name, gender if optional, and date of birth if possible, and purchase date and time. So what time and which date you are purchasing, that is in, and item name, and each item name will have its description. This is an electronic gadget used for so and so, 2 GB RAM mobile phone, like that. And item cost, unit cost, and quantity, how many quantities you're buying, from which a lot of other metrics can be derived. So this is one of the example wherein you have some data collected behind the scenes for doing data analysis. The data that gets stored behind the scenes, this is how it might look like. I'm just trying to show you one example of this from one of the online retails. So you have invoice number, you have item code, what item do they purchase, and you have description about the item. So for example, it says white hanging heart tea light holder, the number of quantities that you buy, and invoice date, what time do you purchase, the date of purchase along with the time, hour, minute, and seconds. And then you also have unit price for that product, what is the unit price, and what is the customer ID, and then finally which country the customer belongs to. So now when you have such a data set, in the back end, what do you think typically companies will do? Or let's say, what will be the use of collecting such data? What do you think of? So let's say the supermarket store or Amazon collected this data from you, and you have it, and this is what we call it as a data set, data in a structured format. You have multiple columns, so you have close to 8 columns in a data, and typically this is where we start doing our analysis. Someone will give the data sets to us and then tell, this is the data that we have, come up with some useful stories or come up with some useful information about this data which will help me to improve my sales. So what do you think, companies might do with this kind of data? So one side there is invoice details. So you have invoice from multiple customers, so you have invoice details. And other side you might have customer information. So for each customer, first time they come in, you get registered in your platform, so customer details you will have. And of course you will have different branch details. You'll have different branch details. Likewise, a lot of other details will be there. I'm just telling you only one or two details that gets typically stored. And these together, they're like, let's say this is one data and this is another data where every row is like a customer, like customer age, gender, and then address if possible, and then what kind of products they typically like, so which segment they belong to, age group, all this gets stored in another data. And branch detail, Reliance store might have multiple branches, so they will know which location it is located. Is it within city or outside city, or is there any other competitor nearby? So all this information gets stored in databases. And typically what we do in data sciences, get some meaning out of all this data, because so far traditionally what people used to do is, people used to build like top customers, top trending products, and high sales branches, like every branch you get to see what is the sales on an average you get, and then you decide, okay, Delhi is the most selling sales, or Mumbai is the most selling branch, selling city, like that. So far traditionally, for multiple decades, people used to store information in databases and then generate some small reports which gives some basic insights about what has happened in the past. So what has happened in the past, so that kind of analysis, we call it as descriptive analysis. So you collect data in the counter, it gets stored in the database, and it's not just one data that gets stored, multiple data get stored in databases. And traditionally what people were doing is to answer the question, what has happened. So what is the top purchasing like product, or who are the customers who buy my products a lot, top 10 customers, and then, so typically across multiple decades people were just doing descriptive analytics, which will be like a Excel report, or it will be like a few PowerPoint slides, wherein someone will aggregate the data and then show it in a very small format. And what has happened is, there is like a lot of useful information that can come out of this data when you do some predictive analytics. So that is where data science started coming into picture. Like, can we take use of certain algorithms, not human beings, certain algorithms, to forecast what will happen in the future? For example, so let's say customer one buys around, let's say for 1,000 rupees they buy some products, and then this is the first time they come in, purchase one, and second time when they come, they purchase it for 10,000 rupees, let's say, and purchase three, some small amount. and let's say we are here, and another customer, every time they come, he or she comes, buys it for a very small amount and then move on. And then there is another customer who bought the items for once and then they didn't turn up. Okay, so different types of customers. Let's say we have their purchase detail. Every circle is like a purchase. Circle size is, let's say, the amount, total amount, invoice amount, the bill amount. Now, can I predict? Can I predict, let's say, in next 1 month or in next purchase, how much this customer will purchase? Whether it will be a small amount or whether it will be a medium amount or whether it will be very small amount. So what is the future purchase value of a customer? So can we predict that? What happens when we predict such things? I will come into that in some time. So when you have customer past details, when you have customer past details with you, let's say 10 years records you have or 5 years records you have about different customers. Certain customers would have come recently, certain customers will be very loyal customers. For last 2 3 years they might be purchasing from you. So from the past details, can you predict future? Can you predict what will happen in the future? And we have a lot of algorithms. That is where machine learning comes into picture. The term machine learning typically we use to tell that algorithms automatically identifies the pattern in your purchases in this example and predict what could be the value that you will purchase in your future purchases. So that part is called as predictive analytics. And in predictive analytics, typically we say what could happen, whether you will come or not, or if you come, if at all if you come, how much will you purchase, and what item will you purchase. What item will you purchase is what typically we say in predictive analytics. That is one stage. And another stage is moment you predict something, have another stage of prescriptive analytics, like assuming that the customer will purchase very less amount. Let's say we are predicting that the customer will buy it for a very less amount. Can we do something on it? Okay, can we do something on it? Can we give some roll out some offers to the customer so that the customer will buy a lot of items? Many times you might have received messages from Amazon or Flipkart or any other e-commerce websites asking you to buy something, or they might be giving you some offer, 5% offer or 10% offer, 15% offer. Why do they give? They don't give it for everyone. So the same message, everyone might not get it. So there are certain customers who are assumed that they will not buy in near future. For them, Flipkart or Amazon will give you a lot of vouchers. So that is like you predicted something and you are going to take decision based on your prediction. So that is usually called as prescriptive analytics. So what can happen is predictive analytics, and what you should do, that is what is called as prescriptive analytics. And these two stages is where data science roles comes into picture a lot. Can someone predict what could happen in the future, and with that can we come up with some suggestions like what should be done? So that is where recommendation algorithms, you might have seen in your Prime Video or Netflix, it will automatically recommend you what movies to watch next, because in the past you have watched some videos or some movies. Based on that, they are predicting that your genre of interest could be action, your genre of interest could be comedy, or your genre of interest could be romance. So in which case they predict what genre you like. Okay, so that is the second stage. And then third stage is I don't just predict, but I do something to increase my business value. So that is where they say, okay, if there is a new movie that comes in action genre, and you, let's say, like action genre, let's say they predict that you like action genre, they will be suggesting that movie to you. So that is how the algorithms like behind the scenes in Netflix or Amazon or Hotstar, all these apps, typically they utilize it from the back end. So that is where your artificial intelligence comes into picture, where I have predicted something. What can I do with that to increase the sales or to increase some metric. So that is, these are the three stages of data analysis. For decades, people were just doing descriptive analytics, but now people started doing a lot in predictive analytics and prescriptive analytics, and this is where there is a large demand. When we feel that some customer is lost, so when we feel that customer is lost, they didn't, so as the name suggests, you have lost these customers almost. Let's say they didn't buy for quite some time, they never come back. Also, their earlier purchases were low end products, that too hardly once or twice. Then what is the strategy the company takes? So they reconnect with you and do one last promotion and take feedback. So for every type of customer, you, I, and everyone get segmented into one or two buckets. So you might be a new customer, or you might be a promising customer, or you might be a loyal customer. For every customer, they have strategies to decide what to happen. Based on these strategies only, you get promotional emails or you get promotional calls from these organization, and algorithms decides what you will do next. And again, prescriptive algorithms will suggest you what the company should do next to retain you into their platform. And that is one example I thought I'll just show you, like from data collection, where you go to the counter and then do some purchases, and it gets stored in the database, and someone just takes and understand what has happened. Then they predict the future, and they also come up with strategies to what should happen to retain you or to bring you back to the store. So this is just one example I took, which is like customer analytics. Many e-commerce website, I would say almost all e-commerce websites, or wherever you have customers, these kind of analysis happens behind the scenes. And not just in customer analytics, there are a lot of applications that we already use in our real time, where data science or artificial intelligence comes into picture. For example, there is an app called as SMS organizer. So it is from Microsoft. It automatically takes your messages, SMSs, and then automatically categorizes your SMSs as personal SMSs, promotional SMSs, transactional SMS, and spam SMS. So all this gets classified automatically, and based on that, you will have different tags or different categories for each of the incoming SMS that you get. And you have personal assistants like Siri, or you have Google assistants, and then you also have Cortana in Windows, right? So a lot of personal assistants have built up based on artificial intelligence technology. And Face app predicts how you look in 60 years, how do you look in 50 years. So all this face changes happens behind the scenes using AI techniques. And then smart speakers like Amazon Alexa, Echo Dot, all these smart speakers runs behind these algorithms. And there are various applications. I would not like to go in details of each of these applications. So the whole idea is data gets collected somewhere. It could be from a machine, it could be from appliances, or it could be from a superstore, it could be from elections. A lot of election data comes in. It could be from clinical trials. Every day there is a lot of tests that is happening, right? COVID test. So all this data is collected actually in a particular website. And let me show you the website. So you can search for COVID data, Hopkins GitHub. So here you will see across countries how many data, how many cases coming out per day. So you will get to see from beginning till end how many reports are there, meaning how many cases are there. So you will get to see in global how many confirmed cases are there. Day wise, you will get to see the data. So you will see for Afghanistan, right from the first day till today, you will get to see what are the number of cases, how many deaths happen, and how many people recovered. So this is the data that typically a lot of journalists uses behind the scenes to come up with stories like how does the peak look like. So if you check out in Google, let's say you search for COVID India cases. So you get to see this graph, right? Many of us would have seen this graph where this is the first wave, this is the second wave, and we are in third wave. And this data is actually gets collected or stored in this particular location that is shown. So if someone is interested, you can just search for COVID data, and you will get to see this, or you can just click on this link in Google search. So one side you collect data, and on the other side a lot of researchers predicting when this peak will happen. That is when you get to see messages like we might get third peak mid of March. The peak for the third wave might come in mid of March is what they're predicting, and it will be way higher than the second peak is what they're predicting. So there is a past data based on which they are trying to predict the future data. And what will once you predict what ICMR or what the government has to do with that, they have to take some measures to prevent a lot of deaths. So that is where your prescriptive analytics will come into picture. So lot of cases your data is much useful, and what you do with data is all about what we like have these algorithms in data science. And why now why data science is emerging now, because before 2009 or before 2005 the data analysis or data scientist term was not that familiar. In around 2010 it started, and now we have a lot of interest in data science now. Typically a lot of job openings are related to data science now. So why is this? Because there is a lot of volume of data that is coming into databases. Like from Twitter you keep getting a lot of tweets, from YouTube a lot of videos gets uploaded every 1 hour, and you have posts from Facebook. So a lot of data gets collected now compared to the data that we had before 2005 or 2000. So the volume of data and the variety of data. Earlier people used to work only with structured data in a tabular format, but now we have images, we have video, we have audio files. So there is a variety of data formats that we have, and the velocity in which the data is coming, the speed in which the data comes in. Every 1 minute you get to see like 1 million images gets added to Facebook, or 2 million. So they keep growing. The amount of images gets added in Facebook, or amount of tweet in a particular minute, it's keep on growing. So the velocity in which the data is coming into these databases is quite high. And also the uncertainty of the data, a lot of data is not clean. There will be a lot of uncertainty in data. So because of all these four reasons, that is the volume of data is high, and variety of data is very different, not just tabular but images, audio files, video files and all, and the speed in which the data is coming, and there is a lot of uncertainty in the data. It's not easy to do analysis on top of this data. So because of these four reasons, there is huge demand for data science. And who should learn data science? Should it be like only people from AI background, or from AI engineering background should read? Because I think I could be wrong. I think the AI department came into picture only few years ago. It is not that you need to have computer science background or you need to have AI background to get a job in data science. So as I said, myself coming from TIPD background, my friend coming from electronics background, mechanical background, we are still working in data science. So any graduate student, I would say, irrespective of whether they come from engineering college or they come from arts, doesn't matter. So it is not just for engineering, or it's not just for arts and science. It's like any graduate now that coming out of college, there is a scope for getting into data science. I know a lot of people from biology background getting into data science, a lot of people from commerce background getting into data science, and a lot of engineering students as well getting into data science. All disciplines and all categories now people started doing data science. So if that is the case, what are the required skills? What skills do you need to get into data science? The skills that are asked during interview is like you should have the statistics background, you should have a software background, you should know how to tell stories from data. But I would say these are all not practical. Like a single person cannot learn all these. So when I entered into data science, I was not having programming background. I code a little bit. Not when I joined, I was coding a little bit. I used to do my analysis in MATLAB, and then I also learned a little bit about LabVIEW to collect data from sensors. And this was the programming background that I had. And in college, of course, I studied C, C++ a little bit. So I had only MATLAB background. I code a little bit in Macron, both the simulation side as well as the script side. So I used to program there, but I didn't have statistics background. I didn't have software engineering background. I started learning one after the other. So during the job itself, that time it was too early. None of us was having good background in all these skills. So companies were a bit okay to hire people with one or two background at least. So we started learning a lot during the projects itself. So it is not possible for everyone to learn all these techniques. Though the curriculum says that you need to have statistics, they teach you programming Python, they teach you a lot of other tools. Even without any programming knowledge, there is a lot of roles which are there in data science. For example, you could learn a tool called Tableau, and using that alone you can get jobs. There are a lot of no code platforms that are available, using which you can do data science. So the message that I would like to convey is, you don't need to have a programming background, you can learn it. And you don't need to have a statistics or any other required background, you can learn it. And then you don't have to be from a specific department to get into data science, or specific discipline to get into data science. Anyone with the interest to get into data science, and if they do the work properly, can definitely get into data science. So what should I learn and where should I learn is what I would like to start with. I would say start with any basic programming. You might not have programming background, that's okay. You start with software tools like languages like Python or R. Doesn't expect you to have code programming background. Little bit of what I would say arithmetic skills and little bit of common sense, if you apply, you will able to learn these programming languages, either Python or R. I'm more inclined towards Python because there is a lot of jobs for beginners, at least in Python. So I would say start with Python. Of course, I will show you where you can go and learn Python to start with. You don't have to be a like full-fledged full stack programmer. You can just know how to handle data and how to play around with certain examples in Python. And then you start doing some basic analysis, and again how to do the analysis, how to where to do this analysis, I will explain. But this is kind of a learning path for someone to get into data science. Few of it might not fit you directly now at this stage, but in general, for anyone who wants to come into data science, this is what we suggest. Start with a programming language. It's not just Python or R. There are a lot of other programming languages like Scala. You have a lot of other languages. Any one language related to data science, you pick it up, start doing some basic analysis, and then you build visuals using Tableau or Power BI. Both Tableau and Power BI doesn't require you to code much. It is just drag and drop. You just have to like select the columns, place it in the chart, automatically it creates the chart and dashboards to you. So you don't have to code anything. It completely there is an opportunity to code, but anyone who is zero programming background can start their career with Tableau or Power BI because it's very easy to use. You go to the Tableau website, there's a lot of videos on how to create visuals in Tableau and even in Power BI, and you can get your entry job using Tableau or Power BI very easily. Of course, you need to learn it a lot, but when you learn or when you get a certification in Tableau, which is easy to get, not that difficult, you can at least start your career with Tableau and work with other data scientists and slowly learn the other terminologies like machine learning, text analytics, and deep learning. At this stage, I wouldn't prefer you guys to learn machine learning or text analytics. I would say, as a student, you should stick to first three of these learning path. One is some basic background in Python and some data analysis skills and a visualization skill, that is Tableau or Power BI or even Excel, any tool which is of interest to you, you can pick it up. Basically, you need to present your results to someone else. So that is where these tools comes into pictures. It's not just analysis you do and then show it in a PPT, but you need to show it like a dashboard. So always presenting is much important when it comes to data science. So you present it using any of the tool like Tableau or Power BI, and then I would say start applying for jobs. When you cross these three stages, I would say you should start applying for internships at least, and then slowly get into data science jobs. Where do you start learning Python from? There are multiple places in which you can start learning Python or whatever this uh, topics that I spoke about. So I'm not promoting any of these things. Any website or pick any academy which teaches you Python for free. For example, Great Learning has one lot of courses in Python for free, so you can sign up for free and then start learning Python for free. And Free Code Camp, so this offers you a lot of topics like Python and various other topics, so you can just learn it for free. You don't have to pay anything for here. And then you have Analytics Vidya, and once you learn all these, let's say you learn Python to start with, you can test your skills in HackerRank. So HackerRank has a way to test your Python skills. There will be a lot of exercises, and to get confident, like whether you learned Python or not, you can practice it here. Once you solve a lot of problems in HackerRank, you can say, okay, you have crossed the first stage in Python, in the learning path, that is, you know Python and you are able to solve some problems in basics of Python. Not just Great Lakes or not just thing, any platform that you think gives you a good background in Python, go ahead and learn it. I've just listed three of the tutorials here which I felt is much good to start with, but feel free to pick any of the platforms which offers free Python course. At beginning, please don't pay for any of these courses to start with, because you need to know whether data science is for you, whether you have interest in data science, and is it like naturally coming for you to do some analysis. Get that tested and then start investing in this particular domain. Otherwise, if you feel that data science is not for you, you can stop it, so you don't spend anything initially. Do your homework without any cost involved. Get to know is if data science is good for you, do you have interest in that, then get into data science in deep. And then you start doing data analysis. For example, you can start with this link, I would say, where they will help you how to do data analysis, or you can start with Twitter analysis. Twitter provides you a free account, developer account. So you can go to developer.twitter.com, sign in. Okay, sign in, and very easily you can scrape tweets. So once you sign in, you will get some tokens in Twitter website, and very easily you can scrape a lot of tweets from any celebrity or any other politician that you're looking for. For example, let me show you how we scrape tweets. So you don't have to worry about the code part as of now. So Twitter will give you a lot of tokens like this, which you can take it, using which you can scrape tweets. And we used to scrape from multiple Twitter handle. For example, recently I was scraping tweets from A.R. Rahman. So I have a Twitter data with me, which has tweets right from his first tweet. You can very easily scrape. For example, let me scrape it for Narendra Modi ji. So his Twitter handle is Narendra Modi. And when you execute this code, this recent tweets will get automatically stored in my Google Colab here. So let it run. It just takes 2 or 3 minutes to execute, and very easily you will get Twitter data. And if someone is interested, I'm happy to share this file as well. And around 3000 tweets we got. For example, here, let's look at the first tweet, tweets.head. The first tweet, the is recent tweet. I paid tributes. This is in 2022. Yeah, recent one. So I pay tributes to great Swami Vivekananda. So you can go back and cross check in Twitter. So you see, this is the latest tweet. I paid tributes to great Swami Vivekananda. So this tweet, we scraped it now, and we get to see number of likes, how many people liked this tweet. So you see around 31k, and that is what you get it here as well. And retweets is around 5,700, and that is what you see here. Retweets is around 5,000. Yeah, by the time we scraped, it was 5,700. Now it is 5,900. So you get to see from which device he has tweeted and which date, and so a lot of information you get. I've captured only few of the information, and you can also of course get the comments later on if you want. There is 1,000 comments for this particular tweet. You can scrape that as well. What do you do? I used to do hashtag analysis, like what type of hashtags are used. This one was for AR Rahman. So let's say we are doing it for Narendra Modi ji. So you get to see top 10 or top 20 hashtags used by a particular user. So our Honorable Prime Minister typically use Man Ki Baat hashtag a lot compared to other hashtags like you have exam warriors, cheer for India, and then Man Ki Baat itself, you see there is a lot of variation. We used to clean a lot. This is just a basic analysis that I'm showing. And vaccine century and target vaccine drive. So largest vaccine drive and all. So there is a place where data get recorded, and you scrape data from that particular place and do some analysis, present it in a visual format. And I used to typically download this as an image and then tweet it, and put hashtags like data science, hashtag machine learning, and also tag that particular user for whom you're doing the analysis. So there is a lot of analysis like Twitter analysis you can start with. It's very easy. You don't need any background, any machine learning background. You don't need it. All you need is just a common sense, like what are the top 10 words, top 20 hashtags, and all. You can simply do this analysis. No programming background is required that much. And you can build a lot of charts or dashboards. So, for example, Tableau is a tool to create visualization without any programming background. So they provide free training videos, close to 40-50 videos you will have. If one go through all this video, they will be comfortable building dashboards in Tableau. And each video is like 15-20 minutes or 40 minutes. And you spend at least 2-3 days or a week time here, and you will have a skill of building dashboards using Tableau, which is very much in demand these days. So as a beginner, when you go to interview and say, I know how to build dashboards in Tableau, you'll have weighted advantage. Even if you're not applying for data science job, even then it will be very relevant during interviews. So if I go to interview and ask certain person, like, what is the additional skills that you got? If someone says that I learned data science on my own, or I did this dashboard, and you showcase what you have done, that will be usually added advantage. That is how you typically differentiate you with others. And then you can of course take a lot of ML courses to do. Once you finish, I would say, first once you cross first three stages, once you cross these first three stages, and I've given links to cross this first three stages, so you can learn Python, do some exploratory data analysis, and then learn Tableau as well. So for all these three, I've given links where you can go and learn and say that I have learned these steps one after the other. And if possible, if you have crossed the first three stages, you can take ML courses, and then you can build your profile. So anyone who goes for interview, I would say, should have a Twitter account definitely, and you should keep tweeting about the topic that you are looking for. I keep tweeting about data science. You pick a topic of your choice, keep tweeting about that. Use a lot of hashtags. and do a lot of analysis and publish it in GitHub. I'm not sure how many of you know GitHub. GitHub is a place where you publish your code. You do some analysis, you publish your code in GitHub, and it will be like an open source. Anyone can see that code, and whatever analysis that you do, create videos and if you do some analysis, publish your dashboards in Tableau public server. It's free of cost, and you don't have to pay anything there. And as much as possible, attend a lot of hackathons and meetups. So if you want to build a career in data science, I would say you can follow these 6 steps. The first step is to choose a mentor. So that is the very first crucial step. And then with respect to data science, learn data science modules for free and understand whether you like data science or not. Because when you get into the job, you should like it. So don't just blindly go for data science because it is giving you a very high salary. Just see whether you like being a data scientist. So travel a little bit like how a data scientist will do. So learn some modules, understand, is data science for me? If not, what else is? So you will get a clarity on that. And if you feel that data science is for you, do some mini project, takes Twitter data, do some analysis, create some visuals, publish it in Tableau server, create some video. So do a mini project and start applying for internships. A lot of companies provides internships opportunities for students. Start applying for internships so you will get a chance to work in a real project. And then I would say build case studies and profile, build your profile, show your work and build your profile as well. And you should have a good profile saying that I was interested in something, I learned it on my own, because companies do expect you to learn on your own. Self learn is some skill that companies typically expect because they can't invest teaching you everything. So you have to learn a lot from by yourself, especially when you get into startups. So you'd say I picked a topic, I learned it myself, I did some work, I applied for internship because I didn't have experience, and I did some real-time project work, and this is my profile. When you do that, then you can start applying for jobs once you're confident. Of course, if you want to collaborate with me, you can write to me at fellowdatascientist@gmail.com. So as I said, as a group of people, we started creating a YouTube channel, and that is Fellow Data Scientist. And we will be publishing a lot of data science videos and then help other people also to get into data science. So that is the objective with Fellow Data Scientists. So you can write to us if you are interested in any of these topics. Thank you.